Hello and welcome to another SilverStripe screencast. Today we're going to be looking at how to improve the quality of our SilverStripe modules so more people will use them. We'll begin by adding and improving tests for our module. We'll learn about a few SilverStripe tools and use them to increase test coverage for the important parts of our code. Then we'll connect our module to continuous integration services. These will monitor our code and let us know when tests break or code quality declines. We'll document our module and learn about some of the ways SilverStripe uses this documentation to power silverstripe.org. Then we'll learn about new code style guidelines and use tools to format our code automatically for us. Finally, we'll add a few community files. These will help us get new users to grips with our module and new contributors to know exactly how they can contribute to our module. We've got a lot of exciting new stuff to cover, so let's get to it. There's a lot of information out there on testing, so it's important that we better define what we want to focus on. You can think of tests as a secondary codebase which ensures our primary codebase, or in this case the module we're building, works correctly. We don't technically need tests to make a module, in much the same way as one doesn't technically need a script to make a movie. It's just a really good idea to have a script. Similarly, it's a good idea to have tests, so we know our module is doing exactly what it should be doing. Some people like to write tests before they write any other code. This is often called test-driven development, or TDD for short. It's an interesting way to build software, and one I highly recommend you try. We've already got a module to work with, so we're adding tests after. Still, having tests, whether we made them before or after the rest of our code, is still better than having no tests at all. So how many tests do we need? This is an interesting question because the answer is, well, it depends. We write tests because we want to know our module works. How many tests we write depends on how many it takes to ensure our code does what it needs to do well. The number of tests is less important than the amount of code they test. After all, I can write 100 tests that check small variations of the same code, but they'll start to decrease in value. What we want to do is cover the important parts of our code in enough tests to make sure our code does exactly what it needs to do. This is referred to as test coverage, or the percentage of code which has corresponding tests. It can be confusing when we first learn about testing to hear all the different types of tests it's possible to write. Testing is full of jargon, so it's again helpful for us to decide what kind of tests we want to write. Unit tests are the smallest and often the most complicated tests we can write. Like their name suggests, we write unit tests to ensure individual units of code work as expected. Given a class of, say, 4 public methods, we'll write at least one unit test for each method to ensure that each method does exactly what it needs to with any input. As a side note, did you notice the structure of my last statement? Given some preconditions, when something happens, we assert an outcome. That's an important structure we'll use again and again. Unit tests are meant to be very small in scope, checking the output of a single method at a time. The less code being tested by a single unit test, the better. This is what makes them so complicated to write. We sometimes have to take steps to ensure that we're only testing a single method. Usually, these steps take the form of replacing real objects in our system with fake objects. This is where it becomes important for our methods not to have side effects or multiple responsibilities. When our methods have side effects, then our tests need to account for changes outside of a single method. When our methods have multiple responsibilities, then our tests balloon out of proportion. Functional tests are a little more down to earth, in the sense that they allow interaction between many objects. With functional tests, we're no longer trying to test a single method, but rather a small slice of the whole system. To illustrate the difference, a unit test might only test that image manipulation functions are called by a gallery class's render function, but a functional test may compare a resized gallery image with a set of expected images. In fact, this kind of test of a set of expected images is called a fixture. It's often an easy way to distinguish functional tests from unit tests. You see, functional tests forego using the fake objects that unit tests do by using real objects. Functional tests focus on the interactions of multiple processes or methods, testing real-world inputs and real-world outputs. Acceptance tests are a high-level overview of the functionality of a module or application. In PHP, these often take the form of, given a URL, when I click these things, then something intended happens. Acceptance tests are similar to functional tests in that they test a slice of the whole application, but where functional tests are of the interactions of multiple objects or methods, acceptance tests are to assert that the whole system fulfills a requirement. As a result, acceptance tests often resemble user stories. They're the answer to the question, does this part of my module or application do what I intend it to do, without the gritty implementation details getting in the way? SilverStripe modules usually have functional tests. This is often the case with add-ons to frameworks, as they depend on some framework functionality. It's often too difficult to fake every part of the framework in order to test a single method. Side effects and interactions are prevalent, especially when dealing with modules that add functionality to pre-constructed CMS interfaces. Functional testing allows us to insert database records, trap emails that have been sent, or even simulate browser requests. It can be slightly harder to narrow down the location of bugs than with unit testing, but it's easier to detect the presence of bugs between objects. Acceptance tests are also common, especially with modules that add visible features to the CMS. It's easier to understand and write tests that replicate how we would normally interact with the system. When I go to my profile and click an edit button, I'm presented with a form. Is understandable because it's an expression of what might actually happen in a browser. Given these types of tests, we're going to focus on functional tests. It's possible to write all three kinds in the SilverStripe project, but I find functional tests will give us the most value in the shortest amount of time. Continuous integration, or CI for short, is what we call web services which continually monitor our code and applications. There are many of these kinds of services, but we're only going to focus on two, Travis and Scrutinizer. Travis is a testing service. When we connect it to our GitHub repositories, it will test the code that we commit to them. If there are errors, we can see this by adding a badge to our README. Similarly, Scrutinizer checks our repository every time we commit code to it, but what it's checking is code quality. There are a number of metrics it can apply to guess if our code is readable, free of errors, and extendable. We tell Travis how to test our applications by creating a file called travis.yml. In the file, we can list things like the versions of PHP we want to test our application against and the environment variables it should set beforehand. These environment variables can reflect different versions of the SilverStripe framework to test against, or different database providers to test against. If our tests need special dependencies installed beforehand, this is the best place to define how those are loaded before the tests are run. The Travis file supports different kinds of events like before script or after success, so not only can we change the system beforehand, but we can also do things depending on whether the tests passed or failed. Once we've got that config ready to go, it's time to plug the module into Travis, create an account and log into Travis. You can connect with a GitHub account, so there should be little to no setup required for this. Go to the account section and click sync. If you can't see the organization the module is in, you probably have to request access to it by clicking the Renew and Add link on the bottom left. Find the organization where the module is, click Grant Access. Another sync should do it. Enable the module repository, and Travis should start watching for changes. We configure Scrutinizer in the same way. First we create a file called .scrutinizer.yml. Then we tell Scrutinizer what language our module is in. Like Travis, Scrutinizer supports multiple languages, including Python and Ruby, which is helpful to remember if we're ever coding in those and need some quality control. We add instructions for which checks to run. Overall, there are fewer things here to define than in Travis's config file, so it shouldn't take all that long. Connecting Scrutinizer is just as easy as Travis. Create an account and log in. You can also use a GitHub account for this. Then click Add Repository. Add the user and repo part of the GitHub URL and pick PHP from the list of languages. Don't worry about running the tests here. We could, but it's better for us to run them in Travis because we can do more with them there. Click Add Repository and we're done. As we change and improve our module, we're going to want to keep docs up to date. If you don't have any docs, now is a good time to make them. Docs are an excellent way for developers and even users to see what your module offers. Perhaps your module adds some CMS fields or a new front-end section. The one we're building here adds a new field to the CMS, so we use docs for developers and CMS users alike. Docs are best kept in docs/en. You can structure them any way you like, but I find it's best to begin with index.md, introduction.md, or even getting-started.md. Something like that is a good way to point readers to the place they will start with the documentation. The .md part is short for Markdown, which is an almost plain text language with support for some formatting elements like headings and lists. You may also have heard of GitHub Flavored Markdown, or GFM for short, which is a superset of Markdown supporting code blocks and other useful formatting elements. When it comes to user documentation, it's best to put this in a user guide file or a folder of Markdown files called user guide. That makes it obvious which parts of the documentation are for developers or general consumption, and which parts are specifically for CMS users. It's also how we load this kind of documentation into sites like userhelp.silverstripe.org and docs.silverstripe.org. This is a good place to point out things like contribution guide, code of conduct, license, and even SEMVer compliance. You can find an example of a README file similar to this by searching for SilverStripe shared draft content in Google. I find it best to document each significant feature of a module in a separate file. That makes it easier for other developers to find documentation relevant to what they're working on. Be sure to include as many images and code snippets as possible, so there are few unanswered questions about how to use your module. You can also include your name or Twitter handle for people to ask their questions on those platforms. Let's move on to formatting our code. If you haven't already picked a coding style guide for your work, may I suggest PSR2? It's a recommended code style for SilverStripe Framework, CMS, and supported modules. It covers things like how to format whitespace and where to put braces. You can read up on it at php-fig.org. Now, you don't have to remember all these rules when you're writing code. You'll gradually learn them over time. For now, you can use an automated tool to reformat your code for you. It's called PHP CS Fixer, and you can download it through Composer. You can use it to transform your source files, and even check before you do with the dry run option. Try to keep commits where you format your code apart from commits where you add features or fix bugs. Mixing the two can make it harder for collaborators to understand the changes you've made and often leads to longer review periods. Remember also that formatting shouldn't affect the behavior of your code. You shouldn't need to bump the version number of your module just because you've applied some formatting. We're almost there. Now's a good time to add a few community files. I call them community files because they don't really help you personally, but they're a great help to other developers wanting to know how to use and/or contribute to your module. When I'm adding these files to my projects, I like to add separate contributing, changelog, code of conduct, and license files. I also add common configuration files like getAttributes, getIgnore, and editorconfig. It can be tricky knowing which license to choose. What do they all mean? Will you get in trouble if you choose the wrong one? MIT and BSD are permissive licenses. They allow modification and distribution. You can use code released under these to build whatever you like. SilverStripe Framework and CMS are released under BSD, as are many of the community modules. On the other hand, GPL is a copyleft license, which basically means if you use GPL code in your module or project, that module or project also needs to be GPL. You can learn more about these licenses and others at opensource.org. You might want to add a contributor license agreement, or CLA for short. This tells contributors how their contributions will be re-licensed as part of the regular release of your module. We have one for SilverStripe, if you want to see an example. Remember to tag a new release and make sure it's available on Packagist, just like we learned in the last lesson. Thanks for watching. If you have any questions or comments, please leave them below.